Hello everyone and welcome. In this video I'm going to show you how to do a one-way independent measures ANOVA using SPSS. In this case I'm using version 25, but if you're using a different version these instructions should be fine for pretty much any version you're using. I'm going to work with a data set from activity 8.2 in the textbook, and this is a one-way ANOVA with 3 groups. And our 3 groups are people who slept for either 3 hours, 6 hours, or 9 hours. And they were randomly assigned to one of those conditions, so sleeping for 3, 6, or 9 hours. And then they recorded the amount of calories, the number of calories that people consumed. So we're going to compare the number of calories in those 3 groups to see if sleep deprivation affects caloric intake. Okay, so to run our one-way ANOVA, we're going to click on Analyze and General Linear Model Univariate. Our dependent variable here is the caloric intake, or calories, and then our independent variable is the group. They're in the 3, 6, or 9 hour sleep group. Our group then is going to move into the fixed factor box. Factor is just another word for the independent variable there. Okay. All right, so we also want to get post-hoc tests. So to get those, you click on post-hoc. And you need to move your factor, the group, into the post-hoc test 4 box. In this case, we're doing the Fisher LSD test, which is not going to make any corrections to the p-value. So click on the LSD for our post-hoc test. There are others listed there that you may find appropriate in different situations, but for what we're doing right now, the LSD test is fine. Okay, and you can click on Continue there, and then under Options, ask for Descriptive Statistics and Estimates of Effect Size. So again, click on Options, and then select Descriptive Statistics and Estimates of Effect Size and say Continue. Okay. Once you've done that, hit OK, and it will run your one-way ANOVA for you. So you can see that we have 40 people in each of our groups there, and then our descriptive statistics table gives us the means for each of those groups. We have standard deviations in the sample sizes there as well. So note here that our standard deviations are not terribly different across the 3 conditions. Like certainly one isn't double the size of another, and so we can be pretty confident moving forward that that homogeneity of variance assumption has not been violated. Okay. Now when you look at the overall ANOVA summary table, there's a lot of information there. The rows that we're most interested in here are the group row and error. So group is the between treatments, and error is within treatments or residual. Right. So our F is 8.912, and that F has 2 and 117 degrees of freedom. It's the between treatment and within treatment, or the group and the error degrees of freedom. Our p-value is very small, right? 0.000. It only goes out to 3 decimals there. And our eta squared is 0.12. You'll note that SPSS only provides eta squared as a measure of the overall effect size. If you want omega squared, you either need to use an online calculator or do it by hand. All right. So this F shows us that our p-value is low, which means that there's some difference somewhere there in the data. Our null hypothesis is that all 3 groups are equivalent in terms of caloric intake, but that does not appear to be the case. So now we need to look at our post-hoc test to see which groups are likely to be different from each other. Okay. So we go down to the post-hoc test box here, or the table. Now to interpret this, what we're looking at is one row at a time. This first row is comparing the 3-hour group to the 6-hour group. The difference in calories between those groups was 482.32. And the p-value for that comparison is 0.002. So that difference appears to be a real difference. It's unlikely to be due to sampling error, given that p-value gives us strong evidence against the null. And then if we look back at our means, we can see that in terms of caloric intake, the 3-hour group ate more than the 6-hour group. Okay. Next, we go and look at the 3 to 9 hour comparison. The 3 to 9 hour comparison there is the second row. Our mean difference there is 483.65, and that p-value is also very, very low, 0.000, which is compelling evidence against the null. And now we go back up to our data and we can see that the 3-hour group ate more than the 9-hour group. Finally, we need to do the comparison between the 6 and 9 hours groups. So look here, the next row is 3 to 6. This row isn't terribly helpful for us because we've already compared 3 to 6 on the first row. It's a difference of 482.32 and negative 482.32. It's just a different direction of subtraction. So we're skipping that row. We're going to the next one, comparing the 6 to the 9 hour. Here, our mean difference is 101.33 and our p-value is 0.51. So that shows us that the difference we're observing there is very likely to be due to sampling error. So the difference there, it's only a difference of 101 calories, and that difference is likely to be due to sampling error. You'll also notice in this table that we have confidence intervals around each of the mean differences. Right? So for example, the mean difference between the 3-hour and 6-hour group is 482.32 calories. That's our point estimate. But when I look at the confidence interval, I'm saying I can be 95% sure that the true value is somewhere between 177.14 and 787.51. So you have 3 sets of confidence intervals here for each of those pairwise comparisons. You have the 3 to 6 comparison, the 3 to 9 comparison, and then the 6 to 9 comparison down here. All right, so as always, if you feel like those confidence intervals for your given study are too wide, that you needed a more precise estimate of the population parameter, then what you need to do is replicate the study with a larger sample size, right? Bigger sample sizes give you much more precise estimates of those population parameters. So one way to think about effect sizes here for the post-hoc comparisons is looking at the mean difference. You can make a guess of, or an estimate based on your knowledge of calories on how big of a difference 482 calories is. Is that a sort of a small, medium, or large difference? Also, it'd be nice to look at standardized effect sizes, Ds, and the confidence intervals around those, but we don't actually have that information in SPSS. If you need the standardized effect sizes and confidence intervals around them, you need to use a different program or an online calculator, and we'll have another video showing you how to do that. Okay, finally, let's take a look at the graph here. To get a graph, you click on Analyze, Descriptive Statistics, Explore, and this is just one way to get graphs. This will work for this. I'm going to move Group over into my box. And you have group in the factor list and the calories in the dependent list. To get plots, you can click on histogram. I don't need a stem and leaf, so I'm going to unclick on that and say continue, and then say OK. And then it's going to give you histograms for each group, and it will also give you the box plots as well for each group on one graph by default. Right? So that should be all you need to know to run the analyses in SPSS for this activity. But again, if you need omega squared, you're going to need to use a different program or do it by hand. And also, if you're going to need D, standardized effect sizes with confidence intervals around them, you'll also need to use a different program or, I guess a different program. And so we'll have another video showing you how to do that. All right, I hope that helps. Good luck.